This one is question 1 from the first of the reliability stats revision quizzes, and it's a probability axioms related question. So A and B are events with a probability of A or B equals 0.8. The probability of A equals 0.6, and the probability of A and B equals 0.3, and it says determine the following: the probability of B, the probability of A given B, and then we have to determine whether A and B are independent and whether they are disjoint. So I always like to draw a bit of a probability tree before trying to work out anything else, and it goes something like this: the probability of A, and I'm going to write in what we know as we go. So we know that a probability of A is equal to 0.6, and so we know that the probability of not A equals 0.4, because the probability of either A or not A has got to be equal to 1. Either A happened or it didn't kind of happen. It's not a Schrodinger's A. Okay. So in this one we want the probability of B given A, and we don't know that yet, we haven't been given that. And this one's the probability of not B given A. And then we're going to have the probability of B given not A, and the probability of not B given not A. So let's see which ones of these we can get. So I'm going to start with this one here, because we've got some information that the probability of A and B is 0.3, and there's only one of these branches that's probability of A and B, and that's that one there. So the probability of A and B is equal to what? Probability of A union B, which is A and B, that's not union, sorry, intersect, and that's going to be equal to the probability of A multiplied by the probability of B given A. So that's helpful because we know this one, that's what we've been given here, that's 0.3. We know that one because we've got that, and so we can solve for probability of B given A, and that'll give us this value here. So the probability of, well, let's put in some numbers first because that might be easier to see. So this one is probability of A and B, 0.3 equals probability of A, so 0.6 times the probability of B given A. So probability of B given A has got to be equal to 0.3 over 0.6, which is equal to 0.5. So that's good, we'll put that one in there, 0.5. And that must mean that the probability of not B given A is also 0.5, because the sum of those two must be 1. Okay, what else? What other piece of information do we have? Last one, we've got the probability of A or B. So what's the probability of A or B equal to? Let's see if we can have an expression for that. I'm going to put it down here because I've got a bit more space. Probability of A or B, or A union B, is equal to the probability of A. I mean, we could probably do this visually first. So let's see, we know that anything that's got the probability of A, so this whole branch is part of A or B, because that's the probability of A. So that's the probability of A here. Now, not all of this side obviously is A or B, because if it's not A and not B, it has neither A nor B. But the probability of B given not A is part of it. So the probability of A or B has got to be equal to the probability of A plus the probability of B given not A. Well, no, sorry. The probability of B given not A multiplied by the probability of not A. So that'll give us the total probability of getting a B, of getting that exact result, that we've had not A and B. Hope that made sense and didn't confuse you. So this is going to be the probability of A plus the probability of not A multiplied by the probability of B given not A. So that is, what have we got? 0.8 is equal to 0.6 plus probability of not A, 0.4 multiplied by the probability of B given not A. Alright, we're almost there. Solve for that. So that means we've got probability of B given not A is going to be equal to 0.8 minus 0.6 is 0.2 divided by 0.4, 0.2, 0.4, and that's going to be equal to 0.5 again. So that means all of these values down the side here are going to be equal to 0.5. Hope that makes sense so far. I'm going to clear some space. Okay, what is the probability of B? So the probability of B is equal to that one plus that one. So the probability of A multiplied by the probability of B given A plus the probability of not A multiplied by the probability of B given not A. So equals 0.6 multiplied by 0.5. So that's 0.6 here, so the probability of A times probability of B given A, and probability of not A, 0.4 multiplied by 0.5, and that's going to give us 0.6 times 0.5 plus 0.4 times 0.5 equals 0.5. Getting a lot of 0.5 answers here. Hopefully that's a correct answer. So next we need the probability of A given B. Probability of A given B. So what's that one equal to? So we've got the probability of so the way to think of this one is it's basically calculating the probability of getting A and B, because the probability of A given B means that A and B have occurred, divided by all the conditions where we're going to get B. So let's just point these out. So we know that B's happened, so that's either going to be the probability of B given A or the probability of B given not A. And given that we know one of those has occurred, one of those two paths has occurred, we want to know the probability that it was in this one. So all we need to do to get that, so the probability of both here, let's write this out. The probability of A given B is going to be equal to the probability of A and B divided by the probability of A and B and the probability of well, not A and B. Not A and B. Does that make sense? So this is all of the, on the denominator here, we've got all of the circumstances that we could have B. So we've got not A and B happening, or we've got A and B happening. So that's all of the possibilities of getting A and B. And then on the top we've got A and B. So this isn't usually how it's written out. I'm just trying to use some intuition to work out how we can find out what the probability is of the top one, A and B, given that it's B. So it's a probability of A given that it's one of these. Hope that didn't confuse you too much. So let's see what we've got from here. So what's the probability of A and B? That's going to be equal to the probability of A, 0.6, multiplied by the probability of B given A, which is 0.5, and we're going to have that as well on the bottom, 6 times 0.5 plus, and what's the last one? Not A and B, which is probability of 0.4 times 0.5. And we got really tiny there at the end. And that's going to give us, it's equal to, let's see, so 0.6 times 0.5 divided by bracket 0.6 times 0.5 plus 0.4 times 0.5, and that's 0.6. And I can tell you, yes, that is correct. I entered it in just a few minutes ago. So I'm just going to clear off a bit more space here, and then we'll do talk about the last two. And we'll use a bit of red, I think. So the last two questions, are A and B independent? Okay, so well, what did we just work out? We worked out that the probability of A given B is 0.6. Probability of A given B equals 0.6, and we also worked out in the first bit that the probability of B was equal to 0.5, and we've worked out over here that the probability of B given A is 0.5. So it's going to probably work out that it's going to be independent fairly obviously, but let's just spell this out. Basically, the probability of A is not affected whether or not we've had B, because the probability of A and the probability of A given B are exactly the same, and the reverse is also true. The probability of B given A is exactly the same as the probability of B, so that is independent. I guess the other thing that we can just prove is the little equation that they give, which is that for independence, a condition of independence is that the probability of A union, what is it? Yep, so if the probability of A intersect B, ignore that little dash here, that's nothing. A intersect B is equal to the probability of A times the probability of B. That's our equation that proves this. So the probability of A union B, what have we got? We were given that is 0.3. 0.3, and then the probability of A, so I'm going to put a question mark there. Probability of A was given to us as 0.6, and the probability of B is 0.5, and we can say 0.6 times 0.5, yes, that does indeed equal 0.3, so yes, they are independent. Now, are they disjoint? What does disjoint mean? If they're disjoint, that means that A and B do not overlap. A and B do not overlap, which would mean that A and B would equal 0. Well, quite clearly A and B does not equal 0, so no, these are not disjoint.